So I was in Vegas 2 weeks ago at the AI 4 conference, huge conference. Kudos to, I think it's Michael, and I forget the other organizer, 5,000 people, 120 exhibitors. And one of the panelists I went to was David's presentation, which he's going to show us shortly, and just super impressed. It was, we've talked a lot in the past about how LLM models are kind of coding to these public benchmarks, yet companies have company-specific needs. And David had an extremely pragmatic, practical approach to that. So, David, we're just delighted you're here, and thank you for taking some time and joining us.
Well, I mean, really, thanks for having me. And it was interesting to hear all that intro at the very beginning as I try to share my screen here. Although, admittedly, every time I share my screen, I always share the wrong screen. I have 3 up right now, but we'll see if this actually works. So give me just a second. But I was excited to hear a couple things. First, it's interesting. Raymond brought up the open source proprietary, and I'll say right now that this some of the stuff, the results don't seem well for Llama, but that doesn't mean that like I'm against open source. I'm very pro open sources, but they each have their own potential uses. The other thing that I thought was interesting was Michael mentioned he was in Arlington, Virginia, and talked about Arlington, Massachusetts. Arlington, Massachusetts is my hometown. That's where I grew up for the first 18 years of my life. So, interesting. I was very surprised to hear that. Okay, so let's see. Did I share screen?
David, share what your day job is, so everyone has.
It's on slide 2. Just as the same thing. So, yeah. Before I get into the actual meat of the presentation, slide 2 is just quick about me, right? Like I'm excited to share this, but who am I before I sort of share? So I am kind of the most senior data scientist in Cox Automotive. We have about a team of 45-ish people, and I work anywhere from mentoring junior colleagues to advising senior leadership to advising product on anything sort of technical in data science, generative AI, ML optimization sort of questions. And in particular, I host a similar sort of thing where this series appears to be, which is education, right? Like I look every 2 weeks, I put forth either something by myself or bring a speaker, and we educate the people at Cox Automotive, general people, not specific to tech, about anything generative AI, what's going on. And in this talk, particularly, I'm going to focus on Battle Royale, which I've actually done 3 times with different models, but we'll get into that as we go along. And previously I used to be at Delta Airlines, and before that I was a math professor at Colgate. So that's my career. And before that I grew up in Arlington, Massachusetts. That was a lot before.
Go Red Sox.
Go Sox. All right, so here's my setting the stage. But before I do, I have 2 main goals from this presentation. Goal 1 is to provide that framework that Paul was saying at the very beginning. This framework works regardless of time frame. Like it worked 6 months ago, a year ago. The framework is going to be using LLMs as judges, and there is some research prior that other people have done that say that this is actually a reasonable technique, and it actually will be in some ways very different from the metrics that exist out there that you'll see on slide 3, where you have things like MMLU and level 5 or something like that. I can't remember off the top, but this is one thing that people tout. But this is a framework to provide you how to evaluate LMs, regardless of what your business use case may be. So that's why I really, really like it. And I think it stands the test of time, having done it 3 times and seeing similar patterns and results that I'll talk about as we get through. So that's goal 1, get the evaluation framework off to you. Goal 2 is actually, I did a battle royale with the 4 models that you see in part 1 here, and I want to give you the results and give you some ideas on how you might interpret and think about and ways to examine the results themselves. So those are my 2 goals. So keep that in mind as we go through. So we'll start off, and I'll kind of talk about the 4 models. Basically, I chose what I would consider the best players out there. So that would be AWS/Anthropic, OpenAI/Microsoft, Google, and Meta, with apologies to Elon Musk. I'm sorry, Grok 2 didn't make the list. But after that, do model features, talk a little bit about these existing comparisons, and then finally really hone in on part 4, which will be the framework and then essentially the evaluations from this particular run itself. And then some last sort of finish up notes, and then Q&A. And we can go wherever we like in the Q&A section. All right, so just big picture, some of the model features. This is Sonnet 3.5, GPT-4o, Omni, Gemini 1.5 Pro, and Llama 3.1405B. And I ran this experiment, I'll say, at the beginning of August in preparation for AI4, but the framework still exists independent of the actual run. They're all text-to-text models. Some of them offer more. In particular, Sonnet can go text to artifact. I'm not going to go down the artifact rabbit hole right now, but you're welcome to. It's on Anthropic's webpage. GPT-4o and Gemini both take images input and provide images output, and GPT-4o can also take in speech input and output. They are similar in terms of their cost structure. The input tokens, these are per million on the left-hand side, and the output per million on the right-hand side. And you may say, wait a second, David, I know that Llama is open source. It doesn't have inference cost. And you're like, okay, yeah, you're right. But I'm hosting it. It's coming from the Bedrock hosting, which is really important from the previous slide. And Bedrock takes their own pricing because they are ultimately hosting this large model. So they're going to take some kickbacks to run it because it does take power to run the Llama 3.1405B. They're all similar in terms of the training data. And lastly, you can kind of put books now in front of the context window. In particular, Google is huge, like 2 million tokens. It's just crazy large. Okay, so that's kind of the general framework of what these models look like. In terms of existing comparisons, Paul said kind of at the very beginning, you have these various frameworks that you can go on and say how it's scored on these various test data sets. And these are good metrics in their own right. But one big issue I have with them is that these test data sets are out there. You could, in theory, train the models with that inside your training data to artificially boost those scores, which is really anti-data science principles. I don't want to completely knock them. I think they serve a good point, and I like looking at them. But that is their one, in my opinion, big shortcoming. One other real important thing that I actually take a lot of credence, if you're not aware of it, is on Hugging Face, there's a chatbot arena where basically the idea is people come in and they've got like 1 million responses so far, and they will put their own prompt up, and 2 LLMs, unbeknownst to which LLMs they are, before will offer 2 responses, and then they ask you to vote. And then they basically aggregate these votes in a ELO rating system, if you're familiar with chess, which that's another whole rabbit hole. But I do take some credence, and there is good order in this ranking in terms of evaluating the LLMs. Okay, so that's kind of a brief sort of existing comparisons. Now I want to get into like what I consider the most important slide of the entire deck. The aim is to give you the framework right now. I will then afterwards talk about the responses. So totally goal 1 right now. So the first thing you got to say to yourself is, all right, what are my LLMs that I want to put in contention to evaluate? For me, like I said, I have the Claude 3.5 Sonnet, I have Llama 3.1405B, Gemini 1.5 Pro, and GPT-4o Omni. So those are my LLMs that you could choose more or less, but here's my contenders. I then come up with a topic list. So for my particular one, I've got 50 topics that I'll show a few of them on the next page because 50 is a lot to really take in, but I'll give you a flavor of what these look like. And they weren't purposeful for Cox Auto, which is where I work, right? They were general purpose where I thought these topics would be good sort of across the board. But if you take this framework, which I hope you do, that you pick the topics that are most useful for whatever your business need may be. So you got your contenders. I've got 4. I then have my topics, which I have 50. And now on top of this, I'm going to take each LLM and ask it, please generate questions in these topics. So for this particular run, I said on each topic, please generate 10 questions. So how I created my question set is I got 4 contenders, 50 topics, 10 questions per topic. So you multiply that out, you get 2,000 questions. So for my run, I had 2,000 questions. You could have different multipliers, but that's how you create the question set across the board. All right, and then part 3, create the responses, which is really straightforward. You just, now independently, you've got the questions. Each LLM, give me your response. What do you give me your answer to each of these questions? So for me, in this run, I have 2,000 questions, 4 contenders. That's 8,000 total responses. This actually doesn't take too long if you're running it in code. You should get a nice developer to do this for you. So now I have my responses. And finally, the big key, I'm going to use the LLMs themselves as their judging on the response set. So on an independent call, I'm going to say, LLM, please, here's a question. here's my 4 responses, and I want you to rank order best to worst on these responses. And there's one real important thing here when you do this. You need to randomly permute the responses. I will get to that reason much later in the presentation. But when you put the responses in for judgment, randomly permute the responses. So you have 2,000 questions, and you've got the 4 answers per question. You get 8,000 total judgments across the board for my particular case. That's the evaluative framework. And now what follows, I'm going to give you some ideas in how to measure the output. And I'm also going to give you my prompts that I particularly use, but you can use something very similar. I want to pause, actually, because I can pause online. Is there any sort of questions on that framework?
There was one question, David.
Yeah.
Let's see, what was it?
What do you mean by permute? Do you mean rotate the order of the data?
So, for example, let's say I ask, what is 2 plus 2? And I want to say, obviously the answer is 4, but they might have some context in terms of that 4, right? So that they all have different responses. But in question 1, I might have Llama's response first, followed by Sonnet's, followed by GPT-4, followed by Gemini. In the next question, I've got a different permutation. There are randomizers out there. So got
it.
Good question, though. Good question. But yeah, that is very important to this framework, as you will see very much later in the slide. I'll bring it back. Other questions, please. It's important that you understand this framework, because if this framework is a little bit confusing, the results will be a little bit harder to interpret. But I think the results, even without, you could still get a lot out of this going forward. But please, I encourage questions. In the AI4 conference, I couldn't really do it that way, but right now I can.
Tim or Adam or others?
Yeah, Paul, this is JC. I have a question. Each LLM is scoring all of the answers, including their own answers.
Correct.
Wouldn't there be like an inherent bias?
Yeah, and we are going to get to that, but they are, at the end of the day, they are getting the same set of rule structures, right? So they all will get to evaluate each of themselves. And as you'll go forth and see, I think you might get in a flavor of why, even though that does happen, you could, in theory, ignore it yourself, and you would actually get somewhat similar results, in my opinion. And I'll give you some evidence to see why.
Gotcha. Okay.
So keep that nugget in your head as we go along.
Sure. Okay.
Michael or Tim? Sorry, Tim. I think Tim's first.
Yeah. So how do you figure? I mean, I'm glad you're doing this. It's really interesting. I'm interested into how you think about topic selection, because it seems like that's the top of the funnel.
It is. So I will give you my topics list in a second to be general, but that's the big key. That what is your business use case? I suggest you running it for yourself and picking the topics that would be best. So if you're, auto, I want to talk about dealerships questions, maybe inventory and things like this, but none of that's in mine, right? You'll see in the next slide, my set. Incidentally, I will say that long ago, I came up with this topic list for this, and it was created by GPT-4, but curated a little bit by me. And this was a full year ago. And I've had some updates because some things didn't work out exactly. For example, there was a computer vision was a topic that got suggested by GPT-4, and asking a question, often the LLMs would ask a non-text based question. And so I had to remove that out, for example.
Tim, did it answer your question?
Yes, that's great. Thanks.
Yeah.
Michael, go ahead then.
Yeah. So for your response set as well as the evaluation, I didn't hear, so correct me if I'm wrong, but did you run to get the responses, did you only run the cycle one time? Because LLMs are known to provide
you could
multiple responses. If you run them 5 times, the answer is going to have 5 variations.
Absolutely. I mean, I did run on temperature 0, but still the point holds clear. So you could, I believe because of the way I've set up this experiment where you have 2,000 questions, like, and as you'll see sort of the statistics I'm going to talk about afterwards, I don't think it would have mattered, right? Like,
and what about the peer evaluation? Same. Did you evaluate 4 times and then take the average, or just one time I'm done?
No, it was all just one time because of the number. And there was an issue with number, but absolutely you could add that to the mix to add some little a level of concreteness. I think you would still get similar results because, again, given that I have a large question list, and as you'll see, I think some of the results speak to that you would, in the randomness, even though there is bias, there's still this randomness that's in there that you would still probably, it would be very highly unlikely that if you ran it with multiple times, that unless you started looking at making it a little more complex where you take different permutations, for example, on a question and then ask them the response, because that different permutations, actually, you would get something potentially slightly different. But still, I would strongly believe the results you'll see, but you would get much in line. And a lot would have to go with the topic list itself, as Tim was just saying, that I think would make the biggest difference.
So because you're the mathematician and I'm not, I believe you that the number of answers and replies and questions are statistically enough to rule out bias because the sample size is quote unquote too small. True?
Right. That's the idea of doing the 2,000 questions and randomizing.
Right, thank you.
Yeah. Exactly.
That's great. Well, keep going, David.
All right. So that's the thing. I think a lot of people understood. It seemed like the framework, which is great. That was my biggest goal of anything else. Now that's just, in my mind, the more fun stuff, which actually gets to sort of the results. But first, to get to Tim's sort of question, here's sort of my a flavoring of what I put out there. So, college math, sentiment analysis, bias detection, code generation, statistics, GenAI, lots of different sort of gen ed topics. In fact, I put 0 automotive topics on purpose because originally this talk was slated for the AI4 conference, so I didn't want to hone in on my own business. Okay, but I do have to mention one annoying piece, but that happened, and largely because of Bedrock and hitting the Llama endpoint. So the entire purpose was to create 2,000 questions. Unfortunately, because I wanted to do this at the very last moment, you notice that Llama 3.1405b only came out at the end of sort of July. So I just got access to it, and then I started running the experiment. Like I did it up to the wire because I wanted to be the most relevant for the conference. But in that, there was issues getting responses from Llama. I didn't have it for the proprietary models, but for the instantiation under Bedrock, I had throttling issues, and getting actual number of responses proved impossible in the time frame. Like I kept getting fail, and then occasionally one would get through. But I only got 485, which is not a random sample, but I did some sub-analysis to convince myself that this would extend if I'd gotten to 2,000. But yeah, that was an unfortunate result. And if I'd had more time, I would have made sure I got the 2,000. Okay. Here is what the actual prompt looked like went into each of the for judgment. Basically, I'm going to provide you a question, 4 answers. Your job is to analyze, and your response should have the following format: answer 1, 2, 3, 4, an assessment, and then the judgment, the comma separated list. That comma separated list is the real big important. 1 to 4 is going to be those values. And then basically, again, inside the inputs, question, and then the 4 answers. If you're not familiar, XML tags have been talked about as a helping hand for LLMs, which is why you see my response and inputs inside XML tags. Okie dokie, let's get on to the fun stuff, in my opinion, the responses. So we'll start with some light stuff, latency, and this is kind of really outside of the evaluative framework, right? This is just how fast the ping. And in particular, Llamas is going to depend on the hosting platform. I use Bedrock, but there's lots of different ways to host Llama. You could see that GPT-4o was the quickest to respond, around 8 seconds. Gemini is the next sort of fastest at around 13, and then around 17 for Sonnet. And then Llama 3.145, again, provider specific, but took around 30, 31 seconds on the median. And there you can see that these long tails, which have cut off at 60 for the purpose of the violin plots, otherwise they get really squashed. But yeah, Llama took a little longer, and yeah, GPT-4o was the 4.0 is ultimately the speed winner. All right, next other sort of basic thing to talk about how verbose these LLMs tend to be. And actually, the proprietary models, surprisingly, are all very similar in terms of that distribution. But those first three violin prompts, you see Sonnet, Gemini, and GPT-4o, all about 500 words on these responses with this similar distribution, from actually there's something wrong with the laugh graph endpoints, but the numbers are right. On the right side, the 3.5 Llama, that took on average 350 words. It's a little less verbose. Okay. This is my favorite slide. So I'm a big fan of rank ordering, which is that's my bias. But I think that is enough a bit to glean out of this. So what this slide is going to represent is how did each judge average rank each respondent. So the top left corner, for example, is what was the average rank that Sonnet 3.5 gave itself across the question set. So if you had an average rank of 1, that means you placed first in every single question. If you had an average rank of 4, it would mean you placed last in every question. So the closer you are to 1, the better you perform. The closer you are to 4, the worse you perform. Or for color schemes, the darker in this case you are, the better. The lighter, the worse you are. And two main things sort of pop out. And I'll say that I've ran this experiment with different models, and I get similar results for both of these observations. One should come as no sort of surprise, and it sort of got mentioned a little beginning about I think I'm better than you all think I am, right? So the self-preferential thing, that's one. And so if you look at the diagonal, you'll see that the diagonal represents that value, and it's always the darkest square in the row, right? That you look at, for example, Gemini 1.5 Pro, Sonnet rated it, gave an average rank of 2.45. Llama gave Gemini 2.42. GPT-4o gave Gemini 2.41. But Gemini thought it was an average rank of 2.15. So, and under different runs, I've seen this behavior as well. Like I said, this is the third time I've run this with different models. But the other neat thing is how you all view me is roughly similar. So if you go the other three numbers, they are pretty close to in line, particularly like, for example, Gemini's row, 2.41 to 2.45, really close. But they're all in the ballpark, but always I view myself as better. It's really fun to sort of watch that. And that is a common theme among these LLMs. If you take this, you can actually basically see that they all thought Sonnet was better than GPT-4o, which is better than Gemini, which is better than Llama. With the small exception, GPT-4o thought it was a little bit better than Sonnet, but that's the self-referential bias. I think you could really take this from this evaluation framework that you could take that sort of order. So that's one way to it. Another way to cut it down is pairwise comparison. So in this case, I'm going to look at, say the first row, I'm going to look at how did Sonnet 3.5 compare to GPT-4o. I'm going to ignore Gemini and Llama for a second for that first row. And I'm going to only look at questions where there's consensus in the evaluation so that all four judges thought a particular answer was better than the other. So they all when Sonnet 3.5 and GPT-4o, they all had consensus 56% of the time, 55% of the time. So over the questions, 55% of them had complete consensus among the judges that either one was better than two, or A was better than B, or B was better than A, all in harmony agreement. And within those consensus, 60% of the time Sonnet 3.5 won, 40% of the time GPT-4o won. Sonnet 3.5 versus Gemini, 60, 2/3, 1/3 basically. Sonnet beat out Gemini, and Sonnet Llama was actually an astounding sort of 95. And actually this is a big, you can see all how did Llama perform? All those real dark greens, like it didn't do well on the pairwise. It frequently was below everything else. But again, I want to go back that open source definitely still has its value. Essentially the proprietaries, with few exceptions, can't be fine-tuned, at least presently, and you get a lot more control over the open source models. They still, and I think they're very valuable, and I just because they perform poorly here is not a bad thing. And actually, somewhat how Llama is structured, there a little bit makes sense, and I'll talk about that very, very end. Okay, so that's the second sort of way, a pairwise comparison. And now I go back to the very, very beginning where I talked about this order bias. So this slide isn't about judging the actual contenders themselves, but looking at the response ordinal rank. So what I mean by this is when I look at the first response, I don't care where it came from. In theory, if it was done right with no bias, I would expect it to appear first, second, third, fourth, 25% of the time. Unfortunately, no matter what model I've put up, that ends up not being the case. And in particular, you'll see that these LLMs prefer the first response. The level of that preference, it depends. But so the top left square, which is Sonnet 3.5, for example, the way you can read that top square is the first response got mapped to the best response 46% of the time, 46% of the time, 45.68. And in general, the way you can see this color schema was the distance away from 25%. So an ideal percentage, you'd want to see these entire, with no order bias, you'd see 25% on every single square. And every square would be a white square. So as it gets more darker blue, that's worse. So a way to interpret this would be to say, all right, each square represents how it views the judge. The lighter the square, the less bias it has. So you can see that Sonnet 3.5 has the lightest square among the 16 possible squares. GPT-4o and Gemini are roughly equivalent. If you really go into numbers, Gemini did slightly better, but not by leaps and bounds. But then Llama really did have a strong order bias. 66% of the time, Llama thought the first answer was the best answer. Okay. So with that, just some sort of last final things before we wrap up. Llama loves to answer in steps. And this is a lot of the time how it's designed to be, right? Like I often for Llama want to fine tune a specific, often a classification task. And I want to provide steps in order to get this. Like this is how it's set up. So even if it's an open-ended question, like 80% of the time I'll say it went into the step answer response. It also loves to talk about the final answer is box. Like it has this thing that in so many of the questions, it responds this way, even if it's an open-ended question. So that could potentially look poorly on the evaluation framework. But again, this is kind of what Llama was a bit more designed for. And again, I talked about the throttling issues. I haven't run it in the past month, so it may be fixed in Bedrock. I don't know, but it was at the time a real problem. Also, GPT and Gemini, they love this asterisk title, asterisk. That is a common theme that I've saw across them in all their responses. Okay, so with that, I really hope you can take this structure and and as I heard from AI, in AI4 and as people are sort of talking about today, there are some slight tweaks you could make to this. You could run with just avoiding the actual self-evaluation and see how things ranked. You could play around with multiple permutations for a particular question because of the order bias. And that would actually be a real good approach in order to say consistency. Like if a model always considered one versus the other, like that'd be a good vote. Whereas if it flip-flopped, you'd be like, well, that's really the order. But that would require a whole extra little time. But one could absolutely do it and go deeper with that sort of experiment. So with that, I'd love to hear more questions, any comments, any clarifications. And please, I'd love it to see if someone else, ran it on a different set of topics to yourself and sent me, what their results were.
So David, fantastic presentation. So kudos for that. What questions do people have? I'll start with one. Did your opening slide say that Claude or Sonnet through Bedrock was cheaper than Llama through Bedrock?
I just copied. So, I guess that's what it looks like. I mean, I copied these. It could be different now, right? Like, these were copied August 1.
Okay. So, as August 1, Bedrock was using its pricing to push it towards Claude.
Yeah, I mean, but if I imagine 7dB, for example, would be a lot cheaper under the, and it only, it 3.1 only just got released, so there might be it might have changed. Like I said, this is, I should say, like, this is of August 1. It's quite possible things have changed as of then.
Yeah. Go ahead, Alden.
Fantastic presentation, David.
Oh, thank you, Alden.
One observation I have is, the prompt where you're scoring, if you try to score all four at the same time, the LLMs tend to be a little lazy with that. So in evals, like typically if you only score one at a time, you'll get like a lot better accuracy. That's what when we observed when we eval like RAG and most of the LLM as a judge frameworks, they also use that just one at a time. So instead of saying like, please rate the answers from 1, 2, 3, 4 and give them score 1, 2, 3, 4. If you just do one at a time, the accuracy.
So you would have to say then, here's the four responses. Please tell me what the best one is. Tell me what the second best one is. Tell me what the third best one is, and then tell me what the fourth best one is.
No, here's one response to this question, score it. And then again, here's question, here's the question response to score it. Like
so the scores have to be 1, 2, 3, 4, right? Everything was in order, a permutation of the numbers 1, 2, 3, 4. Right? Those are the only. So I would have to, if I'm doing that, I would have to say, give me the best answer. If you right, like give me the second best answer.
Based on a scale of 0 to 10.
But I can't do the 0 because it's a ranking system, right? Like I have to know which one's first. So I could ask for a score, but then they could be ties, and then that would not be okay. Also, in my experiments with numerics, I am always very concerned with the, like, say I have a value, I read an evaluation, LLM evaluation, and say like, please give a score 1 through 10. Like, there's correlation on those answers. Like, if 1 is bad, 10 is good, then there's correlation. But it's not like things often get high in the 8 to 10 range, regardless, right. Even if you're bad. Like, it's not
3 times, you'll get different answers.
Also true. So the point is that for the ranking, I would need a way to break ties, right? Like I forced it to say 1, 2, 3, 4. So if I get a raw score, that's not going to get that, right? In order to separate them out, I would have to specifically say, give me the best, give me the second best, give the third best. And there might not even be consistency potentially in that because they're different runs. So they could say like, on this run, it was second, on this run, it was third, and might give it's potential for differences.
Okay.
So, David, if we helicopter back to the headline, so I'm sorry, Alden, would that answer your question? Or
yeah. Thanks,
okay.
Thanks.
David,
Thank you.
At a headline, we had a cage match here of 4 battles. Claude, Sonnet 1, inching out OpenAI. Now, that's consistent with a lot of anecdotal evidence we've talked about in this calls from the last 6 or 9 months where people are really becoming impressed with Claude. And we've seen some benchmark. Is that your overall sense that Claude this is another validation point that Claude is at or beyond GPT-4?
That's, I mean, I would say that's my personal opinion. With that said, do I still use GPT-4? Absolutely. Like particularly for the vision, like I don't think that there's a better vision, both interpreter and output of than GPT-4o. I mean, separately, I've done a whole, inside Cox Auto at one point, and this was months ago, so now it's every 2 seconds things change. But I still think that the Dolly 3, 2, I can't remember which one it is. Whatever Dolly is the most recent release is the best version in terms of the output. And again, as you sort of saw the results, any particular question, like it just tends Sonnet 3.5, like GPT-4o could do better on a particular question and it not be that surprising. We're measuring unstructured things. It's not quantitative anything. But my personal opinion, I do really like Sonnet 3.5.
Yeah. No, but yeah, my point is, I just kind of think you're re-emphasizing is that, a year ago it was ChatGPT 4 and no one felt close. And now we've got at least one closed model close and debatable some of these other models. So
I did like back in the what was it? Claude 2 with GPT-4 like came out, like that there was some, I still thought GPT-4 was better, but I thought it wasn't as far off as people were potentially saying. But
let's do one more question. Go ahead, Tim, and then do open mic for 5 minutes. Go ahead, Tim.
Yeah, so this is great, by the way, really great. And
thanks, Tim.
Good to see somebody who understands the statistics. The question I have, though, the fundamental thing here is that, so there's thousands and thousands of questions. did you do any sampling human evaluation? Because, you know, they do make mistakes. And
Absolutely,
was your
yes.
theory that there is just either so many questions you could bury the mistakes without damaging the statistics, or did you actually sample them to try and check them, or what?
I do. So I've definitely gone to an individual level. For this particular run, I only had a limited amount of time because, like I said, I was running this experiment right up to the wire. So I only got, it was cursory. But previously I have done a bit more deep, and I feel good regarding actually the responses. Like, you have to read and read and read and say, like, okay, like, this is why a lot of the even though it wasn't part of the evaluative framework, I actually asked for the assessment. So if you go back to this slide here, the actual prompt, you see answer one, assessment of answer one, right? And so I would read those and feel that they were in why a lot of the time it voted the order that it voted. With that said, sometimes you got questions that were, they all responded similarly. And so, like, there's some level of breaking ties probably by order as well. Like, if I ask what is 2 + 2, they're all going to answer 4, right? Like, they're all going to get it right. And how do you answer, how do you say which one's better than the other in this? But if I make it college mathematics, now you need an explanation, and who has the better explanation, things like that.
Fantastic, David. Really, thank you so much for sharing, and fabulous work. So kudos, and
thanks, Paul. Thanks for having me.